Here we have a pre-calculus problem on the board. Okay, let's go over the question. A particular polynomial function has the following characteristics. A factor of x positive 2 with multiplicity 3 and p of 0 equals to negative 24, a minimum value of negative 66. For the polynomial function described above, the minimum possible degree is, so we have to find, for one we have the four options, 4, 4, 5, 5. And for the leading coefficient, that is 2. So we have four options for that one too. Okay, so here let's consider the information. So a polynomial has a factor of x positive with multiplicity of 3. So we can write the polynomial p of x equals to x positive 2 to the third power. So I am writing the exponent 3 over here because this factor has multiplicity 3. Okay, there must be another factor, say x positive a. So it may be a linear factor or quadratic factor. So if it is a linear factor, then what degree do we get? So from the first factor, we get x cube, and from this factor, we get x. When I multiply them, I get x to the fourth power. So the minimum possible degree I'm getting over here is just 4. In case, if I assume quadratic factor over here, then I get x cube over the first factor and x square in the second factor. When I multiply them, I get x to the fifth power. So the minimum possible degree is 5. So because we have only two options in the given options. So for the degree, so either we must have degree 4 or degree 5. Okay, so if I have degree 5, what will happen? So whenever a polynomial has degree 5, it cannot have a minimum value or maximum value because the graph may look like something like this. So this is a graph of a odd degree polynomial. So whenever we have a odd degree polynomial, odd degree means in this case we have the degree 5. So whenever we have odd degree polynomial and its graph will look like this, because one of the ends will keep going down and the other end will keep going up. So it's not possible to have a minimum value or maximum value for this one. But in our problem, the question says a minimum value of negative 66. So definitely our polynomial cannot have a odd degree. So it must have even degree. So here among the four choices, option in row C and row D, we have odd degree. So there is no chance to have odd degree, because if you have odd degree 5, we cannot have a minimum value as said in the question. So I think our polynomial must have even degree. So even degree means it must be 4, because we have only one option. So here we have 4, 4. Okay, either option A or B can be correct. So, but one more thing we have to find, the leading coefficient is positive or negative. So that we have to decide. Okay, so here, so the second factor must be linear, so that we get x cube over here and we have x over here, and when we multiply them, we get x to the fourth power. So the degree is even. Okay, so if the leading coefficient for an even degree polynomial, particularly for this polynomial with degree 4, if the leading coefficient is negative, both the ends will go down something like this. So if the leading coefficient is negative, both the ends will go down, and there is a chance to have a maximum value for the polynomial, and we have no chance to get a minimum value because it keeps going down. So we'll not be able to identify where the minimum value is. Okay, what if the leading coefficient is positive? If the leading coefficient is positive, so both the ends of the graph of the polynomial with degree 4 will go up something like this. So here we have a chance to get a minimum value over here. This is a minimum value. So the leading coefficient must be positive, so that we'll be able to get minimum value for the given polynomial. So from the discussion we have done so far, so the minimum possible degree of the given polynomial has to be 4, and also the leading coefficient must be positive, so that both the ends of the graph of the polynomial will go up and will have a minimum value, because in the question minimum value is there. So the correct answer choice for this question is option A.